Hello, we're doing Pascal's triangle. So given an integer num rows, return the first num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of two numbers directly above as shown. So we have a nice little diagram showing us what's happening. Essentially, if we have a number here, or if we want to calculate this number, it's going to be the sum of these two numbers here. So that's Pascal's triangle. They want us to create num rows amount of Pascal triangle. So we're given num rows, and that's how many rows that we need to create for the given triangle. And I think the first thing we need to actually do is create the structure of this triangle. So we're going to iterate through num rows and essentially create a new array every time where the length is actually going to be where we currently are at that index plus 1, because I is always offset by 1. So in the first iteration, I is 0. Oops. And we add 1. So the length of the first array is going to be 1. And we're also going to add 1 to the beginning of the array and also the end of the array. So as you can see here, that's kind of what we're seeing in these areas. So that's actually going to require us to do another loop inside of the new array, because we're going to have to check, is this the first or last? Yes. Is this the first or last? Yes. Is this the first or last? Is this the first or last? No. So when we reach a element that's not the first or last element in the array, we're going to need to do a calculation. We're going to need to check the previous array of j in this case, since this is the new iteration, j minus 1, which will give us this position, and also j, which will give us this position. And that will allow us to calculate the sum for that element. You might be thinking, what if we do a calculation out of bounds? It's actually impossible, right? Because here we're at the beginning and here we're at the end, so we don't do that calculation. Basically, we'll never reach an element where we need to do a calculation where there isn't a available slot to the left and right a bit above it. So that's kind of the trick there. So let's see what the code looks like. All right, so the first thing we're going to need to have is a result array to keep track of our Pascal triangle rows. And at the end, we'll probably end up returning this result. And we need to iterate through and create these rows. So we're going to use num rows here because that is the length of rows that they want us to have. And we're going to want to create the new array given a certain length of that row. So we're going to create a new array. We can do that in TypeScript or JavaScript like so, which is going to be I is offset by 1, so plus 1. Then we're going to iterate through the new array. So we'll have a nested loop in here. As we're iterating through the nested array, we're going to check if j, the index is 0, or the index is at the end, in this case, new array.length, or I plus 1, either way works. If it's at the end, we're simply going to assign that value of j to 1. Else, we're going to need to calculate the value based on the previous array. So else, we're going to assign this to the previous array, which should be inserted into result. In this case, I minus 1 plus, so that is actually going to give us the array. So we'll call this previous, and we'll say that previous array at position of j minus 1 plus the previous array at j. And after that, and we're out of this loop, we can simply push that new array into the result. So we want to check in the beginning of the array and also the end. This is offset by 1, so we do this. So yeah, let's run it. See what we get. Awesome. Let's submit it. And nice. 27.57, not too bad. So we should also talk about the time and space complexity. we have a result array that's going to be the length of num rows, and this represents our triangle. But we also have to create each row, which is going to be at most num rows, but at least one. So it's going to look like n times n minus 1, n minus 2, n minus 3. But that actually just ends up being n squared because we calculate worst case, n being num rows in this case. So the time complexity is also n squared because we have to iterate through said num rows and also iterate through the new array that we calculated, which will give us the same thing here, which will also be n squared. So space and time are both n squared here. Thank you.